Welcome back. Let's take a look at section 9.1, right triangle trigonometry. And so as you can see here, we've got several words, several terms that you should have seen last year in geometry. We have sine, cosine, and tangent. And if you don't know what those are, well, you maybe you need to go back and look at your notes from geometry. But one thing you should know about sine, cosine, and tangent is this SOHCAHTOA. Okay, and remember, sine, cosine, and tangent are ratios of a triangle. Okay, um, so for sine, if you remember, and looking at SOHCAHTOA, sine is a ratio of the following sides. We have opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so make sure you guys have this down. The SOHCAHTOA, one of those silly things that we use to help us memorize. It's a mnemonic device. So hopefully you'll use that to help you memorize what sine, cosine, and tangent. Okay, and so if I want to find the sine of an angle, I need the opposite and hypotenuse, or I need those two sides. And the same goes for cosine and tangent in respectively for the following sides for that. Now, one thing that is new right here is the terms cosecant, secant, and cotangent. Now, those terms, these right here, they happen to be inverses, okay? So the trig functions, those are inverses of sine, cosine, and tangent. So I've got right here, let me go ahead, I'll highlight this area, but sine and cosecant are inverses of one another. So what does that mean as far as their ratio? Well, if they're inverses and the sine ratio is opposite over hypotenuse, then the cosecant ratio will be hypotenuse over opposite, right? We flip the ratio, and that makes it the inverse. So then the inverse of secant is cosine. So if I take the cosine ratio and then I flip it, it's going to be hypotenuse over adjacent. And then for cotangent, it'll be adjacent over hypotenuse. Or sorry, adjacent over opposite. So if you have a hard time memorizing cosecant, secant, and the cotangent ratio, well, I'd say all you need to really do is remember sine, cosine, and tangent, SOHCAHTOA. And then from there, just go ahead and flip the ratio, and then you have the inverses for cosecant, secant, and cotangent. In the end, it's probably easier just to memorize the cosecant, secant, and cotangent ratio. But if you're saying, I don't want to memorize more than I have to, then at the very least, memorize SOHCAHTOA. But you do have to remember, sine and cosecant. Those two are inverses. Cosecant and secant are secants, and tangent and cotangent are inverse trig functions. Moving along right here, we take a look at this, and hey, this is all about SOHCAHTOA and everything that I gave you right here. So maybe if you want to look at your information organized in a different fashion, hey, you could look at the following down below. Now, this is also, let's take a look right here. It says the abbreviations opposite, adjacent, hypotenuse, or opposite are often used to represent the side lengths of the right triangle. Note that the ratios in the second row are reciprocals of the ratios in the first row. So what that means is this. If I take the cosecant of theta, hey, we know cosecant is hypotenuse over opposite. Or it is equal to 1 over sine theta. For secant theta, that is equal to 1 over cosine theta. And for cotangent theta, it's 1 over tangent theta. All right, so if you were to plug those into your calculator, 1 over tangent theta, that will get you cotangent theta. But if you also put, if you want to figure out what cotangent theta is, you could also set it equal to adjacent over opposite, and you will get your same answer, the same results. There's a lot of things going on in this section that's happens to refresh, or it's all a repeat from geometry. So that first one right there, hey, we got our trig ratios down. Now in this next piece, the trig values of special angles. Now, if you recall, we have two special right triangles that we deal with in geometry or in trigonometry. Okay. The first one right here, we have is a 30, 60, 90 right triangle. And I'm going to go ahead and just write that down. 30, 60, and 90. And that'll all be in regards to, or in reference to, the triangle that's on the left. Okay. Now, this applies only to a triangle that has 30, 60, and 90 as the degrees. And what it tells us here is this. The side opposite of the 30 degrees, that's always going to be the shortest side, or the leg. Short leg, x. The side opposite 60, that's the long leg, x. Right here, and then it's also x times rad 3. Okay, or leg times rad 3. And then opposite of the 90-degree angles, which is the longest side, it's going to be 2 times x, or 2 times the leg. So if you don't remember any of this, well, you better go back and remember it. Okay, it's all right here. I'll put in the, I'll add the link of the exact section in geometry that covers this, and I have another video for that if you need more information or a little bit more detail. I want to try to go through this fairly fast. Okay, so that's all in regards to the triangle that you can see there. So it's whatever the leg is, that's the 30 degrees, opposite of 30 degree. That's how long it is. Opposite of the 60-degree side is going to be leg times rad 3, and opposite of the 90-degree side is going to be 2 times x. So then over here on the right side, we have another triangle, and we've got ourselves 45, 45, 90 special right triangle. And remember, that means that this is an isosceles triangle because two of the angles happen to be 40 degrees or 45. So what that will allow me to do right here is say that, hey, opposite of 45 is x. Opposite of 45 again is x. And then opposite of 90 degrees is x times 2. Okay? So 45 is leg, 45 is leg, 90 is leg times rad 2. And so all of that right there, you can see that there's this table. Okay, this big old table here that looks like there's a whole lot of information, but it's nothing really special because you could figure it all out by using SOHCAHTOA and also knowing the sides of the special right triangle. Okay, if we take a look at the 30-degree side, okay, just kind of going over a few of this, right? If I'm looking at 30 degrees, I'm looking at this angle right here. I'm going to go ahead and circle that in green. Okay, that is 30. And for sine, remember, SOHCAHTOA. And for sine, it's opposite, and that would end up being the 1. And adjacent right here is the rad 3. Oh, sorry, it's opposite over hypotenuse. So we got ourselves 1 over 2. That's why right here it's 1 over 2. But then how about let's go ahead and figure out the cosine of 30 degrees. Well, remember, cosine is adjacent and hypotenuse. this rad 3 is the adjacent. The hypotenuse is 2. Therefore, that's how we got 3 rad 2. Okay, let's try it next one. How about for tangent? Well, if I go ahead and erase what I have there, tangent of 30 is opposite, which is 1. Adjacent, rad 3. So I'm going to go ahead right here for tangent. I'm going to put 1 over rad 3. Now, if I look at the answer right there, they put rad 3 over 3. It's not the same. You're saying what gives? Remember, one of your algebraic rules should be we do not have a radical in the denominator. So what do? I'm going to go ahead and mention that again. We will rationalize the denominator. Okay? And when you rationalize the denominator, I'm going to go ahead and take my denominator right here and multiply top and bottom by rad 3. Because when you multiply something by itself, when it comes to a radical, what ends up happening is that it equals that number. Because rad 3 times rad 3 is rad 9. Square root of 9 is 3. So my numerator is square root of 3. My denominator is now 3. And look, we now have the same answer there. Okay, and that's using SOHCAHTOA. And also understand, hey, we have a 30, 60, 90 degree right triangle. If you memorize these, great. If not, hey, use sine, cosine, tangent. Use those ratios to figure out your answer. Okay. When it comes to the 45, 45, 90 degree right triangle, things are pretty much the same. If I want to find the, opposite of 45, I want to find right here sine. Okay, sine of 45 degrees. It's going to be, remember, so opposite over hypotenuse, right? Opposite over hypotenuse. That doesn't work out right there. It's because 1 over rad 2. So what do I do after that? I want to go ahead and rationalize, where we got ourselves multiply top and bottom by rad 2. And I got rad 2 over 2 right here. And take a look, it does match up with rad 2 over 2 in our table. As you take a look at the rest of this right here, now they have right here like cosecant, secant, and cotangent. Right? Remember, they're the reciprocals of cosecant is the inverse of sine. So if for sine of 30 is 1 over 2, right? We take the reciprocal of that, that's 2 over 1, which equals 2, and that's what cosecant of 30 degrees ends up being 2 right there. So you want to find right here sine, cosine, tangent first, and then take the reciprocal of it, and then from there simplify it a little bit further. You do have to do a little bit more work right there, especially when you look at secant theta, because in secant theta, secant 30, right? If we take a look at cosine of 30, right? Cosine of 30 is equal to rad 3 over 2. So secant 30, I got to take the reciprocal, and it becomes 2 over rad 3. Once again, you cannot have a radical in your denominator. So I'll rationalize right here, multiply top and bottom by rad 3. And we now have 2 rad 3 over 3. And guess what? That matches up exactly as what you see on the table right there, 2 rad 3 over 3. So let's take a look at a few questions here. First off, with question number 1, we're going to evaluate the 6 trigonometric functions. Now, when they say to evaluate the 6 trig functions, that means 1, make sure that we're solving for all the different angles there. We have sine, cosine, tangent. We have cosecant, secant, and cotangent. And then make sure no decimals and no radicals in the denominator. Okay, so let's go ahead. Let's take a look at this. First off, I only know 2 out of 3 sides. You could always find the third side. We have the Pythagorean theorem, right? We have, so a squared plus b squared is equal to c squared. So let me go ahead and put it up top right here. A squared, 8 squared plus 15 squared is equal to the unknown, or c squared. You could use your trusty calculator at this point in time. And we've got 8 squared plus 15 squared. That equals 289. If you take the square root of that, we end up with C, or our hypotenuse ends up equaling 17. Okay? Now, bonus points and kudos to you if you remember that this is a Pythagorean triple, 8, 15, 17. So, hey, that's one of those Pythagorean triples, just like 3, 4, 5, 5, 12, 13. You should have those memorized. If not, hey, you should go back and take a look. Pythagorean triples, look those up. So now we have the 3 sides. Let's go ahead. Sine theta. So we have theta over here, and sine is, remember, SOHCAHTOA. I always like writing it down. Hey, I can refer back to it in case you happen to forget something. And so sine is opposite over hypotenuse. The opposite right there is 15. The hypotenuse is 17. And now from here, we're trying to find all 6. So the inverse of sine right here happens to be cosecant. So let me go ahead right here to the right of it, put cosecant theta. And remember, it is going to be the reciprocal, the inverse slash reciprocal. It's going to be 17 over 15. Okay, so now we found cosecant theta. Just like that, really simple. Next up, we go cosine theta. All right, we have cosine is adjacent, which is 8. Hypotenuse is 17. Or adjacent means it's next to the angle, but it can't be the hypotenuse. Okay, that one is always its own entity. And the inverse of cosine is secant theta, and that's going to be 17 over 8. And then finally, we have tangent theta, which is opposite over adjacent. So opposite is 15, adjacent is 8. And the inverse is cotangent. And so cotangent theta is 8 over 15. Just like that, we figured it out. Pretty simple. Okay. If it was only that simple all the time, right? Let's go to number 2 next. So let's repeat this process. We do need to figure out the third side right here. And we'll use the Pythagorean theorem. 4 squared plus b squared is equal to 8 squared. Okay. We need to find one of the missing legs. So let's go ahead. We got to get this things by itself. 8 squared minus 4 squared. So 64. We have that minus 16. And we end up with 48, right? So b squared is equal to 48. When you square root both sides right here, now remember, you do not want to deal with decimals. So let's just go ahead. We put this in simplest radical form. Looks like I can get 16 times 3, right? And the square root of 16 is 4. So we got 4 rad 3 ends up being this missing side. So now we can go ahead and use SOHCAHTOA to help us find 3 of the trig functions, and then the inverse right after that. So let's start with sine. So I got sine theta. Here's theta right here. And sine is opposite over hypotenuse. So we got 4 over 8. Okay, really easy. What a great start. Okay, and then so we take the inverse of that, which is going to be cosecant. So cosecant theta is going to be 8 over 4, which ends up equaling 2. And then for sine theta, let's make sure we simplify that down, and that'll be 1/2. All right, so we got 2 out of 6 done, or 1/3 of the problem. Next up, let's go ahead and find cosine theta. And so cosine theta right here, we have, remember cosine is adjacent, so we got 4 rad 3 over hypotenuse, which is 8. So right here, we got to simplify this down, and 4 and 8 simplify down to 1/2, so I got rad 3 over 2. We find the inverse, that's secant theta, and that's going to be 2 over rad 3. We're in trouble because we do not want our answer to look like that. So, look like what, you say? Remember, no radicals in the denominator. So we're going to rationalize. I'm going to multiply top and bottom by rad 3, and this now becomes 2 rad 3 over 3. All right. So now we are more than halfway done right here. Let's go ahead and figure out tangent theta. And then tangent is opposite over adjacent. So we got 4 over 4 rad 3. Let's go ahead and eliminate the 4 or simplify that down. So I'll end up with 1 over rad 3. Remember, the problem right here is we have rad 3 in the denominator. So we got to rationalize this. Multiply top and bottom by square root of 3. And so we got rad 3 over 3. Finally, we have cotangent theta. And that's equal to, we got 3 over rad 3 right there. But once again, we cannot have a radical in our denominator. We're going to rationalize right here. And so I got 3 rad 3 over 3. And guess what? The 3's cancel out, and I'm left with rad 3 right there. Let's take a look at number 3 next. All right, so now they gave us right here, tangent theta is equal to 1. And so you're going to have to put a little thought into this because they don't give you really too much information. Remember, tangent is, we have SOHCAHTOA is opposite over adjacent. So what they're saying is that, hey, I have 2 sides. And if I take the opposite and adjacent sides right here of theta, and let me go ahead, I'll put theta in, guess what, I have a triangle already there. So in the triangle, I've got put theta as the angle. And they're saying if I take the opposite over adjacent sides, it's supposed to equal 1. Well, how about if we just keep this real simple and we'll put opposite as 1, adjacent as 1. 1 over 1 equals 1. I could put 5 over 5, 6 over 6, 7 over 7. It'll equal 1. That's all that matters. So then, how about the hypotenuse? Think, what type of a right triangle do we have here? If 2 legs are the same, this is an isosceles triangle. And if it's an isosceles right triangle, these 2 angles right here that are missing are both 45 degrees. And so what does that mean? It means that this is a 45, 45, 90 degree right triangle. 45, 45, 90. And remember we talked about opposite of 45 is x, leg, 45 leg, opposite of 90, leg, rad 2. So if my leg is 1, then what that tells me, we have 1, 1, rad 2. So my hypotenuse right here, guys, is square root of 2. Now I have all 3 sides of the triangle. Now I can go ahead and evaluate the other 5 trig ratios. Okay, so if we know that tangent is equal to 1, I'll just go ahead, that's a gimme. So I have tangent theta is equal to 1. That should also lead us to the fact that cotangent theta is equal to 1 as well. Because what's the reciprocal of 1 over 1? Still 1 over 1. Then we have, let's take a look at sine theta. So if we take a look at where theta is, sine, we have SOHCAHTOA. opposite over hypotenuse, it's 1 over rad 2. But that's a no-no. We got to rationalize. So we multiply top and bottom by rad 2. And we have rad 2 over 2. So then we find the inverse of that, which is cosecant theta. And then the reciprocal is 2 over rad 2. But in order for us to solve this out, we got to multiply top and bottom by rad 2. So we have 2 rad 2 over 2, which ends up equaling rad 2 by itself. All right, there is that. And then finally, let's go take a look at the last one we haven't looked at. It was just cosine theta. Cosine, so adjacent over hypotenuse. Adjacent is 1, hypotenuse is rad 2. So let's cut to the chase right here. Since it's the same thing as sine theta, it's going to be rad 2 over 2. And then the inverse of cosine is secant. And so secant theta right here will end up being rad 2 as well. Okay? And so now you know how to find the sides of a given right triangle. For number 4, let's just go ahead. I'll just set it up right here. But based on what we see, if I have a right triangle, we have theta. They tell me what sine is. Remember, sine is opposite over hypotenuse. So katoa. So opposite right here will end up being 3. Hypotenuse is 19. What we are missing right here is one of the legs. So how do we find it? Use that Pythagorean theorem. Okay? And I would probably keep that as, let's maybe simplify radical to be able to help you through a question like this. All right, let's go ahead and move on down. Since we're taking quite a bit of time, it's actually a long lesson because there's so much review right here. Let's take a look at number 5. So we're trying to find the value of x. Okay, if you look at the drawing right here, they give us one angle and they give us x. There's 2 ways for us to solve this. I believe the way they want us to solve it right here is using, since they tell us it's 30 degrees, okay, we've got ourselves a special right triangle, and it is 30, 60, 90. Remember, side opposite of 30 is x, opposite of 60, x rad 3, opposite of 90 is 2x. So it looks like, what do they give me? They give me 16. That right there is your hypotenuse. Hypotenuse is opposite of 90 degrees. Now, what I'm showing you right here are very good SAT type questions, even like SAT 2 type questions later on that you may see. If the hypotenuse is opposite 90, well, what I want to go ahead and put right here is 16 is equal to 2 times x. Right? 90 is the hypotenuse, and that's equal to 2 times the leg. So if I get x by itself right here, I could divide both sides by 2, and x is equal to 8. Now, you're saying I found x, and x is right there on the triangle. Not necessarily, because that x actually represents the side opposite of 60 degrees. Okay, so if I want to find the side opposite of 60 degrees, it's leg times rad 3. So my actual answer right here is going to be 8 rad 3, and that is your solution. Without having to use your calculator and setting things up, there you go. And if you're saying, what do you mean by using your calculator and setting things up? Well, what you could also do here is this. If I have 30 degrees and I have adjacent and hypotenuse, okay, you gotta think, well, what is that? SOHCAHTOA, right? Let me go ahead and put right here. Once again, SOHCAHTOA. Which one happens to be adjacent and hypotenuse? Cosine, right? So what I could do right here is put cosine 30 is equal to adjacent over your hypotenuse, like that. And then I can go ahead and figure out what x is. Multiply both sides by 16. If you plug into your calculator 16 times cosine 30, you should end up with x is equal to 8. All right. But it was so much easier using 30, 60, 90. Because let's see how fast we could use 30, 60, 90 in problem number 6. Or actually, sorry, we got 45, 45, 90 right here on number 6. Remember, opposite of 45 is leg, 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 rad 2. Opposite of hypotenuse. So if I take a look at the information, they give me the side opposite of 45, and that's 20. So what that tells me here is that my leg is 20, the two legs, because remember, this is an isosceles triangle. 90 degrees is leg times rad 2. So let me go ahead, 20 times rad 2, just stick that in right there. I found my answer to the hypotenuse, just like that. All right. There you go. 9.1 in a nutshell, which happens to be about 2-3 sections of geometry. All right. If you need to go back, I will put the links in the comments area so you can check out and refresh your memory of some good old geometry. If I helped you out in any way, help me out. Make sure you guys like the video. Please subscribe. Leave some comments. And have a great day.